All right, hi everyone. Today we are going to continue learning how to factor polynomials, and we're going to do something today called factoring a difference of squares. And we're going to talk about what that means in a second. So difference of squares, it's a polynomial that will look a certain way. So we'll talk about that in a second. But again, we're still factoring. So that's the whole goal of this unit, is just factoring polynomials. Okay, so let's go ahead and start. We're going to start by reviewing something we already know how to do. So we are just going to multiply these binomials. This is something we learned a few weeks ago. And remember to multiply binomials. So binomial is something that has two terms. So this has two terms, this has two terms, and we're going to multiply these. And the way that we do that is basically just distributive property. So we start with the first term, and we distribute it to both terms over here. So that would become x squared minus 4x. And then we do the same thing with this second term here. So we distribute the 4, so that would be 4x, positive 4x. And then we distribute it over here. That would equal negative 16 when you multiply. And then normally we would combine like terms. But if you notice, we have negative 4x and positive 4x. So what's going to happen when we combine those? Well, that would just equal 0. And we typically don't write 0x, right? We just kind of get rid of it. So these will go away, and we have x squared minus 16, and that's all that we would have left, right? So we would just call this our final answer, x squared minus 16. All right, let's go ahead and do the other one. So same thing here, we're just going to distribute twice. So we'll start with the first term, 5m times 5m, that would be 25m squared. And then 5m times negative 3, that would be negative 15m. Okay, let's do the 3. So the 3 is going to go to the 5m. So 3 times 5m is positive 15m. And then 3 times negative 3, that would be negative 9. And notice for this example, the same thing is going to happen, right? We have negative 15m, positive 15m. So if we were to combine those, they would just equal 0. So we're just going to cross them out. And then we'll bring down what we got left, 25m squared minus 9. Okay, so let's take a look at these examples here. I gave these problems on purpose because I wanted to make a connection with the way that these look. So what happened each time? Well, each time, these two middle terms, they canceled each other out, right? Because one was positive and one was negative. So they canceled out, and we only had these two terms left over here. And the reason why this happened is because if you look at how the problem started originally, we had a plus sign and a minus sign. And this number over here was the same thing, right? It was x and x, 4 and 4, and then a plus sign and a minus sign. So we ended up with the same exact term, except one was negative and one was positive. Same thing on the other side, right? We had 3 and 3, but one was positive and one was negative. So the resulting polynomial, so this answer that we got here, this x squared minus 16, or the 25m squared minus 9, those are called differences of squares. And the reason why they're called that, the word difference, so remember in math, the word difference means basically a subtraction problem, right? So it just means subtraction. And squares, so squares, you want to think of squares not like the shape square, but in math, when you square something, squares would be something that is something you could take the square root of. So like 100 would be an example of a perfect square because you could take the square root of 100. It's 10, right? Another example would be 25 because you could take the square root of 25. It's 5. So anything that has a perfect square root, we're going to call those squares. So for example, that resulting, I'm going to use this one as our first example, x squared minus 16. X squared minus 16. This is called a difference of squares because it's a subtraction problem, and both of these terms here, both of these terms are perfect squares because you can take the square root. So the square root of x squared, what times what equals x squared? Well, that would just be x times x, right? So the square root of x squared is x. And what's the square root of 16? So the square root of 16, what times what equals 16? Well, that would be 4 4 times 4 equals 16. So you'll see, if we wanted to go backwards and factor something that looked like this, all we would have to do is figure out these square roots. Because if you look at how the problem was originally written, it was x, 4, 4. And those are just the square roots of these two terms, x and 4. And we would just need to make sure that one of them is positive and one of them is negative. So we're going to do a bunch of examples, but anytime you have a polynomial that looks like a difference of perfect squares, you can factor them pretty easily as long as you can find the square roots. So that's what we're going to do today. Okay, so factoring a difference of squares. So the first thing that you need to do is make sure that it is actually a difference of two perfect squares. So I'm going to zoom in right here. It'll be in this format. So it has to be subtraction. It can't be addition. It has to be subtraction. And both terms have to be able to take a square root, a perfect square root. So something squared minus something squared. And those can be factored pretty easily. You just take the square root of each. So in this example here, a squared and b squared, it would be a, and then the square root of b squared would just be b. And then you make sure that one of them is positive and one of them is negative. And that's it. So you just figure out the square roots, and then you're trying to make sure that one of them is positive and one of them is negative. That's how you factor a difference of squares. So the steps here, you always want to look for a GCF first. That's just always your first step of factoring. That's always what you should do first. So we're going to look for a GCF first, and then we're going to find the square root of each term. So let's go ahead and do that. Does this have a GCF? That's always what we should look at first. And it doesn't look like it does, right? So there's the only number in front here is a 1, and this doesn't have an x, so we can't pull anything out of that. So we do need to make sure it's a difference of squares. It is a difference. There's a subtraction sign. And then can I take the square root of x squared? Well, let's see. What is the square root of x squared? What times what equals x squared? That would just be x, right? And then what's the square root of 25? What times what equals 25? And now you should know most of your perfect squares, at least from 1 to 10. You should just kind of know those in your head. If you don't know them in your head, you can use a calculator. Just find this little symbol on your calculator, this square root sign, and just type it into the calculator. So the square root of 25 is 5. Once you figure out those square roots, we just fill in the factors. And you make sure that one of them has a plus sign and one of them has a minus sign. So we have x and 5, so we're going to write out our two factors. We're going to make sure one's a plus and one's a minus. So in the first part, it's going to be x times x, and in the second part, it'll be 5 and 5. And you can always double check if you wanted to, right? You could always multiply these out and make sure that you end up with x squared minus 25. So this would be our answer here. So that's how you factor a difference of squares. Another way to think about this, I'm just going to show you another way to think about this, just to maybe make it make more sense for some people. So x squared minus 25. You can think of this as a trinomial. Even though it only has two terms, you can think of it as a trinomial if you imagine that that middle term is 0, 0x, right? Because technically it is 0. So 0x. And again, typically we don't write the 0, right? That's why it would normally just look like this top part. But if we write it in, I'm going to show you a different way to think about this. So if we try to factor this trinomial the way that we normally factor a trinomial, which means we start with factors of 25, right? Factors of 25. Well, it's either 1 times 25 or 5 times 5. And then you pick the ones that would add up to 0, right? Well, that would be 5 and 5, as long as you make one of them negative. And then you could factor it into x plus 5 and x minus 5. So it's basically the same thing as factoring a trinomial. And if you want to do it this way, you totally can do it this way. Just make sure you write in that 0x and figure out which factors would need to add up to 0. So that's just another way to think about it. All right, do some more examples. So we're going to go ahead and factor all of these. So let's make sure, so remember, we need to make sure it's a difference of squares, and then we need to find the square roots. So let's go ahead and get started. All right, Is this a difference of squares? Well, it's definitely a difference, right? So because it's subtraction, so we're good to go there. Let's find the square roots. What's the square root of n squared? Well, that would just be n, right? N times n is n squared. And then what's the square root of 64? You should probably know that one. The square root of 64 is 8. So we found our two square roots, and then we can just go ahead and write out the factors. So one's going to be a plus, one's going to be a minus, and then we would have n and 8. And that's it. So difference of squares, they're pretty quick to factor. All you got to do is find those square roots, and then you're good to go. Okay, same thing here. So make sure it's a difference. Yep, it's a difference. It's subtraction. And then we just find the square roots. So the square root of c squared is c. The square root of 100 is 10. 10 times 10 is 100. And then we can write out our factors. So plus, minus, and then c and 10. All right, that one's done. Okay, the next one, so the order does matter because it's subtraction, right? So it is subtraction, so we're good to go. But a lot of people would want to write this as x plus 9 and x minus 9, which is not what you should do because it wasn't written in that order. The x was not first like it normally was. The 81 was first. So order does matter. You got to be careful with that. So the square root of 81 is 9, and the square root of x squared is x. But since the 81 came first, that means we have to put the 9 first. So when we write our factors, we're going to put the 9 first. So 9 plus x, 9 minus x. All right, so the next one, let's see, it's definitely a difference. So we're good to go there. Let's see if it's got square roots. Can I take the square root of 4t squared? So to do this, when you have a number in front like that, just find the square root of the number and the square root of the letter. So the square root of 4 is 2, and the square root of t squared is just t. So that would be the first part. And then the square root of 1, well, that would just be 1, right? 1 times 1 is 1. So we figured out our two factors. So we can go ahead and fill them in. So plus, minus, and in the front, we're going to put 2t, and then we'll put 1s over here. So this would be completely factored. All right, and then the next one. So be careful with this one. These do have perfect squares, right? So you can take the square roots of those. However, it is not a difference. So because of that, like this is a plus sign. That is not a difference of two squares. This cannot be factored. I'm just going to call it prime. Remember, we call it prime if it can't be factored. It cannot be factored because it's not a difference of squares. And there's no GCF or anything, so it just can't be factored. So be careful with that. All right, and then the last one. The last one, it does have a minus sign, so we can try to factor it. Let's see. So I got numbers in front of both of these, right? You do want to make sure, just see if there's a GCF. I don't think anything goes into 16 and 49, right? So there's no GCF. So let's just go ahead and take the square roots. So what is the square root of 16? Well, the square root of 16 is 4, and the square root of a squared is a, so that would be 4a. And then the square root of 49b squared, well, that would be 7b, because the square root of 49 is 7. And let's go ahead and write out our two factors. So we've got 4a and 7b. So that would look like this. 4a plus 7b and 4a minus 7b. Okay. A few more examples to do here. So let's go ahead and take a look at these. Okay, so this one's a little bit different when you're trying to find the square roots here. So square root of 81, we should know what that is, right? That's just 9. But this time the n is n to the 4th power. So how would I take the square root of n to the 4th power? So you have to think about, what times what would equal n to the 4th. So remember how exponents work. If I want to end up with an n to the 4th, I need to be able to add the exponents. And what number would be the same thing if we could have the same number So n squared times n squared, that would work, right? N squared times n squared would equal n to the fourth, because when you multiply exponents, you just add them. So when you're taking the square root of an exponent like this, you're basically just cutting this number in half, and that would be the square root. So if you just cut this number in half, so n to the second, that would be our square root. And then the square root of 25, that would just be 5. So we can go ahead and fill out our factors now. So we have 9n squared and 5. So 9n squared plus 5, 9n squared minus 5. Okay, same thing with the next one. So we have x to the 6th power. So if I want to figure out what the square root of that is, I basically need to just cut this in half, right? So half of 6 is 3, x to the 3rd, let's just double check, x to the 3rd times x to the 3rd. Would that equal x to the 6th? Yes, it would, because remember, you just add the exponents when you multiply them. So that would be our square root here, x to the 3rd. And then the square root of 16 is 4. So those are our two factors, x to the 3rd and 4. So when we go ahead and fill them in, we would have x to the 3rd plus 4 and x to the 3rd minus 4. All right, one more example, and this one has coefficients for both terms. So let's go ahead and figure this out. The square root of 64, well, that is just 8, and the square root of m to the 4th, remember, we're just cutting this in half, so it'd be m to the 2nd. All right, and then the square root of 9n squared. So what's the square root of 9? That would be 3. And then the square root of n squared is just n. So those are our two terms, 8m squared and 3n. So let's go ahead and fill in the factors. 8m squared plus 3n, 8m squared minus 3n. Okay, and that is how you factor differences of squares. That's it. And just remember one thing that I wanted to point out again. If you ever are confused and you want to just check your work, remember you can always just multiply these out and make sure it works. So just keep that in mind. All right, guys, see you next time.